Right now, as you are watching this, the National Weather Service's own Weather Prediction Center has just issued a forecast discussion warning that the same stretch of the country baking under extreme heat this week is about to flip into a heavy rainfall and flooding threat by Saturday, with forecasters specifically flagging the possibility of upgrading part of the southeast to what they call a slight risk of excessive rainfall in the coming updates. That warning went out this morning, the 22nd of July. At the exact same time, hazardous heat is not actually leaving the country. It is simply relocating, building over the Four Corners region as monsoon moisture takes hold across the southwest through the weekend and into next week. This is not a new pattern this summer. It is the same one that has now played out at least 3 separate times since late June, and every single time the transition has looked less like a gentle cool down and more like the atmosphere violently wringing itself out. When the heat dome that trapped the country in record temperatures over the 4th of July finally broke, more than 9 inches of rain fell in 24 hours just northwest of Des Moines, Iowa. Suburbs west of Chicago picked up 4 inches. A week and a half later, slow-moving thunderstorms parked over Huntington, West Virginia, and flash flood watches stretched from Nashville to Lexington to Charleston. Meteorologists have a blunt way of describing this exact behavior. Heat waves often end with a bang. This is the story of why the same maps that were glowing red and orange with extreme heat warnings for weeks are now starting to turn a deep, saturated black with extreme rainfall totals instead, and why that shift is not actually good news. No hype, no exaggeration, just what the forecast data says and what the science behind it means. Drop a comment and tell me if the heat has broken where you are yet, and if it has, whether it broke quietly or with a storm. If you want grounded weather breakdowns instead of vague headlines, subscribe. It is free. And a like helps this reach people who need to see this before their own local weather flips. Let us go for 5,000 likes on this one. Thank you. Now let us get into it. To understand why a heat wave breaking is not automatically a relief, you need to understand what is physically happening in the atmosphere in the days before that break arrives. During a prolonged heat wave, the air sitting over a region does not just get hot, it gets loaded with moisture, because warmer air is physically capable of holding significantly more water vapor than cooler air. A relationship atmospheric scientists have understood for more than a century. Every degree Celsius of warming allows the atmosphere to hold roughly 7% more moisture, which means a heat dome that has been sitting in place for a week or more is not simply hot, it is also quietly accumulating an enormous reservoir of water vapor with nowhere to go, because the same high pressure ridge trapping the heat is also suppressing the rain that would normally release some of that moisture along the way. When that ridge finally breaks down, whether because a cold front finally manages to push in from the north, or because the jet stream simply shifts, all of that accumulated moisture does not disperse gently. It gets wrung out, often within a matter of hours, as cooler air collides with the humid air mass the heat wave left behind. AccuWeather senior meteorologist Brett Anderson described this exact process while forecasting the collapse of the heat dome earlier this month, explaining that the atmosphere becomes loaded with moisture that gets wrung out as the heat dome collapses and cooler air moves in from the north, a transition that produces powerful storms with lightning and rounds of torrential rain capable of triggering flash flooding well beyond what the region's drainage systems are built to handle. This exact sequence has now repeated itself across the country multiple times in under a month, and tracking the pattern from one event to the next makes the current forecast far easier to take seriously. The first major example arrived right around the 4th of July when the heat dome responsible for record-breaking temperatures across the central and eastern United States finally gave way. In the Dakotas, Nebraska, Iowa, and Minnesota, the breakdown was already complete by that Saturday, and the rainfall that followed was extreme by any measure, with more than 9 inches falling in 24 hours just northwest of Des Moines and roughly 4 inches soaking suburbs west of Chicago in a single burst. Days later, in southwest Texas, forecasters were separately warning of a risk for potentially life-threatening flash and arroyo flooding as an entirely different piece of moisture pushed through. By the middle of July, the pattern had shifted eastward, with a flash flood threat continuing from Tennessee to West Virginia as rounds of heavy rain and scattered, slow-moving thunderstorms swept across the Midwest and South. Flood watches covered Nashville, Lexington, Kentucky, and Charleston, West Virginia on the same weekend that slow-moving storms were actively flooding neighborhoods in Huntington. And in a detail that captures just how quickly this pattern flips from one extreme to the other, the same stretch of days that brought flash flooding to the east also brought rising fire danger to the conditions, and gusty winds were pushing wildfire risk higher across Washington and Oregon, even as more than 2/3 of the entire western United States sat under some level of drought. The same week, in a strange symmetry, some parts of the Northeast briefly enjoyed sunny skies and comfortable temperatures, only for forecasters to warn that hot weather was already set to return by midweek. This is not a region cooling down and staying cool. It is heat and flooding trading places across the map on a roughly weekly cycle. That brings us to what is happening as of today specifically, and why the maps themselves are worth paying attention to, not just the temperature numbers. When meteorologists talk about extreme heat, they typically communicate it using color-coded risk maps, with the most dangerous conditions shaded in deep magenta or dark red, the visual shorthand for genuinely life-threatening heat. When the threat shifts to rainfall, forecasters switch to a completely different scale, one built around rainfall totals and flash flood risk. And at the most extreme end of that scale, where rainfall totals climb into double-digit inches within a very short window, the color coding on many of the maps meteorologists actually use shifts into the darkest shades available, deep purples and near black, because the standard color gradient simply runs out of lighter colors to represent how much rain is falling. That is the visual signal currently building over parts of the southeast, heading into this weekend. According to this morning's forecast discussion from the Weather Prediction Center, which specifically flagged elevated moisture and enhanced atmospheric forcing, raising the threat for what forecasters call efficient rainfall producers. Thunderstorms capable of dropping extreme totals in a short period, rather than spreading the same rainfall out gently over a day. The same discussion extended that threat into the northern, intermountain west and the Rockies as moisture and energy lift along the northwest side of the same high pressure system, currently anchoring hazardous heat over the Four Corners region. In other words, the exact ridge of high pressure currently baking the southwest is simultaneously the mechanism pumping moisture into the storms threatening to flood the southeast. Two seemingly opposite disasters being generated by the same single atmospheric feature at the same time. It is worth stepping back and naming why this particular summer keeps producing this specific whiplash between extremes rather than a more ordinary mix of hot days and rainy days spread out evenly. The same high-pressure ridges responsible for this year's heat waves have consistently been unusually strong and unusually slow-moving. The same blocking pattern behavior meteorologists have flagged repeatedly this season, and a slow-moving ridge does two things at once that a fast-moving one would not. It holds heat in place long enough to push temperatures to genuinely dangerous, sometimes record-breaking levels, and it holds the surrounding atmosphere in place long enough for that same air to keep absorbing moisture from evaporation, transpiration, and any nearby bodies of water for days on end before anything finally breaks the pattern. A heat wave that lasts 2 or 3 days rarely produces this kind of violent flooding transition when it ends, because there simply has not been enough time for the atmosphere to load up with that much extra moisture. A heat wave that lingers for a full week or more, the kind this country has now seen multiple times since late June, is a fundamentally different setup, and the flooding that followed the 4th of July heat dome, along with the flooding now forecast for this weekend, both fit that same longer duration pattern rather than being isolated, unrelated events. There's a genuinely important comparison sitting inside how different communities have handled this exact heat to flood transition over the past month, because it mirrors something that shows up in nearly every kind of extreme weather event once you start looking for it. Cities and counties with modern stormwater infrastructure, designed and regularly upgraded to handle rainfall intensities well above historical averages, have generally weathered these flash flood events with property damage and travel disruption, but comparatively few casualties. Smaller towns and rural counties relying on older drainage systems, built decades ago around rainfall assumptions that no longer match what is actually falling out of the sky, have been the ones producing the more dramatic scenes, swollen creeks, overtaking roads, water rescues, and homes flooded well beyond what residents expected based on the area's own flood history. The gap is not really about how much rain falls in any single storm. It is about whether the infrastructure underneath that storm was built for the atmosphere we actually have now, loaded with roughly 7% more moisture for every degree of warming, or for the atmosphere of several decades ago, when heat waves broke less violently and rainfall extremes like these were rarer. So what does this actually mean for you, wherever you happen to be watching this from? If you live anywhere in the path of a heat wave that has been sitting in place for several days, the practical lesson from this entire pattern is that the end of the heat is not automatically the end of the danger, and in some cases it is closer to the start of a different one. Watching for flash flood watches and warnings specifically in the 48 hours after a prolonged heat wave finally breaks, rather than assuming the worst has passed once temperatures start dropping, is a genuinely useful habit sitting directly inside everything we just walked through. If you live somewhere currently baking under the heat that has now shifted toward the Four Corners and the broader Southwest, the same warning applies in reverse since monsoon moisture arriving on top of extreme heat is precisely the combination capable of producing exactly this kind of violent transition once it finally breaks in your own region. The honest, grounded summary is this. A heat wave does not simply fade away once it ends. It often collapses violently, releasing the enormous reservoir of moisture it quietly built up while the high pressure ridge responsible for it sat in place. That exact pattern has repeated itself across the United States at least 3 times since late June, from the historic 4th of July flooding in Iowa and Chicago to the flash flooding that swept from Tennessee to West Virginia in mid-July, and it is forecast to repeat again this weekend, with the National Weather Service's own forecasters warning of a heavy rainfall and flooding threat across the southeast, even as hazardous heat simultaneously builds over the Four Corners under the exact same weather system. The maps meteorologists use to track this shift literally run out of standard colors at the most extreme end of the rainfall scale, turning into the deep purples and blacks reserved for the kind of rainfall totals capable of overwhelming drainage systems built for an earlier, less extreme atmosphere. That shift from a map glowing red with heat warnings to one turning black with rainfall totals has now happened at least 3 times since late June, and every single time, the underlying cause has been the same slow-moving ridge, simply relocating rather than actually breaking down. We are going to keep tracking this as the pattern continues to cycle through the rest of this summer, sourced the same way we did today, straight from the National Weather Service's own forecast discussions, and the meteorologists actually explaining the mechanism behind each transition, not recycled headlines. Subscribe so you do not miss the next shift, because based on the pattern of the last month, it will likely happen again within a matter of weeks. And leave that comment below. Tell me whether your own area has already been through one of these heat to flood transitions this summer, and how bad the flooding actually got compared to the heat that came before it. Because behind every one of these maps is a family in a Des Moines suburb who watched 9 inches of rain fall in a single night after weeks of drought, a neighborhood in Huntington, West Virginia, wading through water that was not there 24 hours earlier, a firefighter in the Pacific Northwest, watching the exact same heat responsible for that flooding somewhere else quietly drying out the forest around them, and a family in the Southwest right now watching their own local forecast, wondering which version of this pattern arrives at their door first. 5,000 likes on this one. Let us go. See you in the next one.